My name is Venkat Dinesh Raj Khanuri. This video is made for the purpose of reporting for a network management module, MSc IT, Leeds Beckett University, September 2024. Student ID 775159998. The topic I chose is SNMP for diagnostics and troubleshooting network problems to improve network performance. The experiment is set up in a lab environment with two computers pre-installed with the SNMP and PRTG. So the SNMP is here used to collect and analyze data, while the PRTG is used solely for the visualization purpose. One of the computer is set up as a network administrator, while the other one is set up as a test workstation. The first thing we start with is gather the IP address of the uh, test workstation, then open PRTG on the admin computer and click on device, add device, and enter the test workstation name, the IP address, and then check the SNMP for the version and the community string, and then click on add. And the next thing we'll be doing is adding sensors. So the first sensor would be SNMP traffic. Here we've set we have selected Ethernet as that's how the devices are connected. So we've selected Ethernet as only option, and you can choose whichever as per requirement. And then we've selected, then we've given or we have uh, made a setting so a warning gets triggered and notification gets triggered as soon as the utilization or the bandwidth of the network crosses 40 Mbps. So you can see I've created a email and notification trigger along with the warning. And the second one would be SNMP CPU load. Same way like the traffic, we have also created a warning and a notification trigger at when the CPU reaches 70% of its utilization. We get a warning, and we also get a email and notification push notification from PRTG. And the third one would be system uptime. Similar to traffic and CPU load, we have also created a warning and a notification trigger. So when the computer has not been up for more than 100 seconds, you will see the warning. If it happens again and again, it's easy to identify that that particular device is having an issue and is rebooting multiple times. And fourth one uh, would be SNMP trap receiver. It will collect the alerts, let's say the messages, drops, errors, or any warnings, and it will display in its logs as alerts. So we've created few notification triggers as well. We've also tried adding a SNMP memory. As a sensor, but looks like there was an issue with the lab, and it was not letting me add SNMP memory to the set of sensors that we are dealing with today. So I've left SNMP memory out of the experiment for now. And then coming to the first scenario, we simulated workload of a normal or IT employee who uses multiple applications in their work by opening multiple Chrome tabs and opening YouTube videos in order to generate load and traffic, CPU load and traffic. Uh, Once we did that, uh, you can see immediately the CPU load and Ethernet traffic sensors have given warnings saying that the utilization is high. You can see in the graphs the utilization. The CPU has almost reached 99% of its utilization. Uh, these diagnostics or this real-time data helps with the checking what's the problem or what's happening, or it also helps us with determining that the CPU is an old one and it's due for an upgrade. So once we go back and clear some of the Chrome or decrease the load, the utilization falls back. It shows that the that we can keep an eye on the devices which are under our network and troubleshoot as per our diagnose what issues or what errors there are through SNMP. So this is the information. So once the Chrome tabs are cleared, everything went back to normal. CPU utilization has lowered, and the network traffic has gone down as well. You can see these spikes there where it has gone down. Yeah, and in the second scenario, what we recreated was losing network or network drop. So we disabled Ethernet on the test workstation to simulate network drop, and immediately in PRTG, we can see that the Ethernet has turned red, showing that it's completely gone. And we can see a new alert has been created on the right-hand top corner, which shows that the Ethernet is down. And all these alerts are stored in SNMP trap. So once the Ethernet has gone down, all the other sensors have gone down as well. So you can see the Ethernet is completely gone down, and even we lost the information from CPU and system uptime as well. So SNMP, it gathered the traps and it send an email or alert onto the screen. So this would be how the notification or the trigger would look like when something goes down and everything, when the network goes down and everything else goes down as well. This is how the email would look to a network manager. So as soon as they see this, they can immediately react and look at what's the issue and troubleshoot the issue. Once the network issue has been cleared, all the CPU loads or the Ethernet traffic has come back to normal. You can see the graphs. This shows that SNMP helps with troubleshooting as well. This is the end of the second scenario. So here, what we are saying is we are seeing the reports from PRTG, which shows the the duration to which we ran the experiment, which is around a period of 4 to 5 hours. You can see the info of the duration, and it gives a detailed report on how much at what time either there was a loss or how much high the utilization was from time to time. Everything can be checked, and the network administrators can go through all this data, which helps them in clearing the issues faster and improving the overall network performance and eliminate losses or drops. Shows the amount of data or to it, and PRTG log shows when the system has gone down or how much the loss was or how long the system was down for, and each change it creates a log. So we have all the information which helps us improving the network overall. So yeah, I would say SNMP does a great job in doing both diagnostics and troubleshooting network problems in order to improve the overall network performance. Thank you.